A person has loss due to property damage and loss due to bodily injury. Losses are independent and uniform on 0, 3. Find the expected loss due to bodily injury given that at least one of the losses is less than 1. So let X be the loss due to property and Y be the loss due to injury. And since this is the given condition that at least one of the losses is less than 1, so let's call that A. A is the event that at least one of the losses is less than 1. So then A is represented by the following disjoint union. So when X is between 0 and 1, so then this first loss is satisfying the condition that at least one of the losses is less than 1. So it means then the second loss could be anything, and the entire range of the second loss is 0 to 3. And if X, if X instead of being between 0 and 1, if X is greater than 1 and less than equal to 3, then since X is not satisfying the condition of being less than 1, then Y has to be less than 1. So, okay, be more accurate to call it like this. So here X is less than 1 and Y could be anything. Or if X is greater than or equal to 1, so now since X is not satisfying the condition of being less than 1, so then Y has to be less than 1. So Y has to be less than 1. For calculations, it will not make any difference whichever kind of inequalities you put, because it's a continuous situation. But still, this is the more accurate way of writing this step. Okay. Now, the area of this region, remember, the original distributions are uniform for both X and Y, and we can see that this distribution is also uniform. So, so the area, so for when two variables are involved, you need to know the area of the region, and if the distribution is uniform, then the joint PDF is simply 1 divided by area. In case of one variable, we know it's 1 divided by length of the interval. In case of two variables, it's 1 divided by area of the region. So that's why we want to know the area of this region. So when X is between 0 and 1, the length along the X-axis is 1 minus 0, and Y is between 0 and 3. So the length along the Y-axis is 3 minus 0. So it's like a rectangle of this length and this height. Similarly here, X is between 1 and 3, so the length along the X-axis is 3 minus 1, and the length along the Y-axis is 1 minus 0. So the total area of the region is the sum of these two rectangles, sum of the areas of these two rectangles, so that ends up being 5. And as we said, original distributions are uniform, so this conditional distribution that we are interested in is also uniform, and the density would be f of xy given a, so that'd be equal to 1 over 5, 1 over the area of the region. And here we are just writing what the bounds of the region are, like here. So we want the expected value of y given a, right? Expected value of the expected loss due to bodily injury, which we call as y. So you want expected value of y given a. So that will be equal to the expected, the double integral of y against this corresponding PDF, f of xy given a. And then when x is between 0 and 1 and y is between 0 and 3, it's this one. So it's y times the PDF. PDF is 1/5. And similarly here we have the part where x is between 1 and 3 and y is between 0 and 1, the second part. And when we integrate this, we are having it first with respect to x, so 1/5 can be pulled out, and integral of dx is just x. Y is a constant, so y times x. X from 0 to 1. Similarly here, x between 1 and 3. So you substitute the limit. 1 minus 0. Here it's 3 minus 1, upper minus lower. So this ends up being 1/5 integral of y dy plus, since this is 2, so this is 2/5 integral of y dy, and then the integral of y is y squared by 2. So this one would be y squared by 10, and this one would be 2y squared by 10. Substitute the limits, and we end up getting 1.1. That's choice C.